Now that we have learned to convert moles of one substance to moles of another, we want to add in the second step of stoichiometry. Although moles are useful, we know that that's not how we measure substances in the lab. In the lab, we measure most substances by mass, and our units then would be grams. In order to change the mass of one substance to moles of another, we can use the mole ratio from scale 1 as well as the molar mass from our previous unit. So we jump right into the first example. We are given the balanced equation and asked to determine how many moles of sulfuric acid are needed to neutralize 173 grams of sodium hydroxide. If you again look at the 3 steps of stoichiometry, the first step is to change mass of the given to moles. Since we were given grams of sodium hydroxide, this is where we start our stoichiometry process. We again start with what we were given, which is the mass of sodium hydroxide. We learned in the previous unit that we can change grams to moles using the molar mass. So if I add the mass of 1 sodium, 1 oxygen, and 1 hydrogen from the periodic table, the molar mass is 40.00 grams. We learned in the mole unit that when you are converting from grams to moles, the value always gets smaller. So we set up our conversion factor with 1 mole on the top over 40 grams. So this becomes 173 divided by 40, which is 4.33 moles of sodium hydroxide. Now, this step was needed in order to accomplish our goal, but we're not done yet because this gave us moles of sodium hydroxide. We need to change this into moles of sulfuric acid. When you're changing from moles of one substance to moles of another, that's when you use your mole ratio. So we're going to move on to our second step. We start with our answer from the previous step, which was 4.33 moles of sodium hydroxide. When we're setting up a mole ratio, it's between the substance we're given and the substance we're trying to change into. Remember, you create your mole ratio using the coefficients. Since we are changing from 2 moles of sodium hydroxide to 1 of H2SO4, that's a decrease in moles. So the smaller value goes on top, 1 H2SO4 over 2 sodium hydroxide. So basically you're multiplying this value by 1/2, which is 2.16 moles of sulfuric acid. I always check back to see. I was supposed to find moles of sulfuric acid. That's what I have, and so this is my final answer. And I don't need to use the final step of stoichiometry.